Okay, welcome back. Okay, so in this video, we're going to be looking at expanding and collecting. So expanding refers to multiplying out brackets. I reckon you've come across it before, sometimes called distribution, because really the thing inside the brackets, I want you to think of, let's just put a circle around it, join those brackets up. Think of that x plus 5 as it's just a number. But because we don't know what x is, so we're starting to introduce some letters in here. The letters are really just, think of it as a placeholder for a number. So they represent numbers, but we don't know what they are. So we just have to use a different symbol to represent a number. But when we get to collecting, we're talking about collecting like terms. The letters will come into it. It'll be slightly more important. Okay, so anything inside brackets, I want you to think of as just a single number, but it's been split into two. So just as an aside, if we have 2 times 6, that's a nice easy one, isn't it? We know that's 2 times 6 is 12, but what I want to show you to sort of relate it to some of this, we could break that 6 apart. So we could write it as 2, and I'm going to use brackets here. So a number outside of brackets means it's this multiplied by the thing inside the brackets. Let's call this 2 plus 4. So 2 plus 4, odd maths would tell us to do this first, so we get 6, and then we multiply it by 2, we get 12. But what's going to happen here is, instead of doing what's inside the brackets first, we can actually multiply and expand the brackets away by multiplying what's on the outside by both terms on the inside. So I'm using some mathematical language here. Terms are things that we can add and subtract together. So 2 and 4 are terms. As this is written without an equals, this is an expression. As soon as you put an equals after it, it becomes an equation. Now, a term can be things multiplied or divided together, not just numbers on their own. So that's a situation like 2a is 2 lots of whatever number a is, but we still think of 2a as a term that can be added or subtracted to other things. Okay, so in this case, so we know this is what we're talking about. All I've done is broken this 6 into 2 plus 4. So when we multiply this 2 to what's inside the brackets, we multiply the 2 by the first term, 2 by the second term, and we keep that plus. Well, because this is positive and that's positive, we're just multiplying positive numbers here. So we get 2 times 2 is 4, and 2 times 4, so we're still adding them together, is 8. And then 4 plus 8 is still 12. So sometimes when I'm trying to multiply big numbers in my head, if I can split a big number into 2 easier to deal with chunks, then add the results together. That's sometimes how I do large multiplication. So if I'm multiplying something by 23, in my head, it's easier to multiply something by 20 and also multiply that same thing by 3 and then add the results together. So you can, once you get used to this, it helps to multiply bigger things if you can break them into smaller chunks. Okay, so that's sort of the maths that's going to be going on. Okay, so let's get rid of that. So I only put a full ring around that so you could see that this was just one thing. And we're multiplying 3 by whatever x plus 5 is. But because we don't know what x is, what we do is just multiply the 3 by the x and the 3 by the 5. So I might write out an in-between step before we get to the final answer. So this is 3 times x. So notice we have a curly x here, and that's because when we're multiplying, we don't want to get a thing that represents a number and an operation confused. Plus 3 times 5. So really, once we expand this out, we end up with 3x, and we don't really write the times. We just assume that when we have a number and a letter, they're multiplied together. So this is 3 lots of x. X, if we had x plus x plus x, that's x 3 times. That's sort of the relationship between addition and multiplication. And then we add 3 times 5, 15. So expanding out these brackets, we end up with 3x plus 15. Okay, so I'm going to skip this step for the next one. So again, we take the number on the outside, we multiply by each term on the inside. So here, because we have a number in front of the a, we multiply the 2 and the 2. So this is 2 lots of a. So if we double that, we're going to have 2 times 2 is 4 lots of a. 4a. And then this is a positive. Think of this as the same as adding a negative, subtracting a positive. They're interchangeable. So we've got 2 times 5 is 10. And because that's subtracting, we keep that. Because a positive and a negative, we're still going to end up with a negative. Okay, so that's essentially it. Because these numbers are both even, we could what they call factorize. It's not in our textbook, but it is essentially starting with this and realizing this is 2 times something and this is 2 times something, so we could create the brackets and take that factor of 2 out, and we'd end up with this again. So it's factorizing is going that way, expanding is getting rid of the brackets. Okay, so this last one, this is a sneaky positive 4. So we've got 5 times 4 is 20. But because it's a negative 5 times positive 4, we get a negative answer. And then, because we're subtracting here, we could think of this as subtracting a positive. But really, yeah, we can say that. Subtract a positive, so I'm going to keep the subtract. 3 times 5 is 15, lots of z, but because we're calling this 3 positive, we end up with a negative 15. And notice how I've written z with a little line through it. Mathematicians like to do that so that we don't accidentally get confused with a 2. Negative 15z. So really, these two negatives, they match. So this is really a positive. So we've got negative 20 plus 15z. In my head, the way I would deal with this is I would think of this as, let's just write it out again, negative 5, or I would think of subtracting a positive number as adding negative 3z. because I know that they're different. So it's the same as subtracting a positive. So this and this are the same, but when I multiply it out, I still get the negative 20 at the front. Negative 5, well, I'm just going to carry that plus down. Negative 5 times negative 3, and negative times a negative gives us positive 15. So we end up with the same thing. Just depends on which way around you look at it. Okay, so that's essentially expanding. So we start with something in brackets, there's a number outside, and we multiply that by everything on the inside. Students quite often get caught out. They multiply by the first thing and they forget to multiply by the next thing. We could also have more than two things inside the bracket, so it's got to multiply by absolutely everything. Okay, so now we'll talk about collecting. So collecting, we're really talking about like terms. So this isn't like my favorite terms. These are the ones I like the most. Like as in alike. They're kind of like whole numbers are like terms. Multiples of x are like terms. So if I have 2x and I have 3x and they're added together, I can say that's 5x. So that's essentially what collecting is. So we'll do these examples from the book. So this is the next one of them. Okay, so I'll do this 3 at the top. 5x plus 3. 3x take away 7. So I'll do the top 3, but I'll write them going down. 4a, 7a, 6, 3x plus 6y, curly y, take 2, take away 8x plus 5. Okay, so we'll do these one at a time, and I'll just talk about why some things are like terms and why some things aren't. Okay, so like I said before, this is 5 lots of x. This is 3 lots of x, and you can think of that operation as the sign attached to this. So combining like terms, we would take, this is like saying we've got 5 apples, we're going to take away 3 apples, so we end up with 2 apples. But the 3 and the 7 here, these are like terms because they're multiples of 1. It's probably the best way to describe it. This is 3 ones, and this is 7 ones. So we're starting with, you think of the ones as bananas. So we've got 5 apples plus 3 bananas, take away 3 apples, take away 7 bananas. A negative number of fruit isn't really useful, but just to sort of explain why these are different. So these are just whole numbers, multiples of 1. So really, this equals 5x take away 3x. We're going to end up with 2x. 5 of these things, take away 3 of these things. And then we've got positive 3, take away 7. 7's bigger than 3, so we're going to end up in negative land. So positive 3 take away 7 is going to give us negative 4. So let's just color code that. and we'll put a line under that to sort of show where those things came from. That's fine. Okay, so in this next one, here we've got 4A, 4 lots of A, take away 7 lots of A, plus 6. So the 4A and the 7A, because they're both multiples of A, they're like terms. This 6 is just 6. We're just adding 6 to whatever this lot of A's is. So we've recognized that these two terms are like terms. So we go 4, take away 7 is going to give us -3, but don't forget their A's, -3A. And we can't really do anything with this, so we're just going to bring the 6. We just keep adding the 6 to this that is those things collected. I hope that makes sense. Okay. So now we've got 2, 3, 4. We've got 5 terms this time. Okay, so just looking, we've got 3x, 6y, take away 2, take away 8x. So our 3x and our 8x are like terms. And then we're adding 5. So it's like I did at the top, a wiggly line and a wiggly line. Okay, so now we're ready to simplify this down. We're starting at 3x. We're taking away 8. So 8's bigger than 3, so we're going to end up with -5x. We don't have any other y terms, so we just have to bring that over here. There's nothing we can collect it with. And then we've got -2 plus 5, and they're just lots, 2 lots of 1 and 5 lots of 1. So these are like terms. -2 plus 5 is going to give us +3. Hopefully that's making sense. We've got 3 more examples, and these 3 examples also, first we have to do some bracket expanding, and then we collect terms that have the same, well, the same likeness about them. Okay, so these 3 examples: 2 outside brackets, x plus 3, 3 lots of 8, 2 plus 6, 2a plus 5. So these are getting more and more involved. 5 lots of 2x 5, x plus 3, take away 3 lots of -2x plus 2. So we're going to have to be using all the things that we've learnt so far. When we multiply these here, we've got to recognize that we've got 2 negatives going on. All right, so let's just start at the top. First thing, we're going to, I've missed something. Take away 6. I thought that was a bit plain looking. Okay, so first thing we're going to do is expand out these brackets. So we'll write that out, and then we'll collect the like terms. So we've got multiplying that and that, just so we don't forget. So we've got 2x plus, so this is +2. It's going to give us a positive. +2 is 6. 2 times 3 is 6. Take away 6. And so we've got 2 lots of x. There's no other x terms, so that just stays the same. These are lots of 1s, and I hope you can see that if we start at +6, and we subtract 6, we're going to end up with 0. So essentially they just disappear. So this equals 2x once we've collected those together. They cancel each other out. Okay, so this one, let's just put a line there. So this one, we've got 2 lots of brackets to multiply out. We've got a, take away 2 in here, 2a plus 5 over here. So I'm not going to put the arrows. So the first step is I'm going to multiply out each of these brackets, and then hopefully we'll have the space to collect the terms together. So the first one, 3 times a is, I'll write it up here a bit, 3a, take away 2 times 3 is 6. We're going to carry this plus on. So this is positive 6 times positive 2 is 12a. And that's a positive times a positive, so we're adding again. 5 times 6 is 30. So just to have a little quick look, we've got 3a and 12a, and we've also got 6 ones and 30 ones. That's how I like to think of it. So we've got 2 things to collect together. So 3a plus 12a, this equals 15a. And then this is, think of this as negative 6 plus 30. This is going to end up at positive 24. So sometimes the operation and the sign, they're sort of the same thing, but you've got to understand that sometimes they can cancel, they can clash, they can be different, they can be the same, and you just have to know how to do it, how to deal with them. Okay, so this one, this is the last example. I might expand these brackets, and I'm going to write it below, and then we'll collect the like terms over here. So the first one, we got 5 multiplied by all this stuff here. So 2 times 5 is 10x. This is 2 lots of x. And multiplying that by 5, we get 10 lots of x. And then positive times a positive, 3 5s are 15. Now here, I want you to think of this, let's write this bit in red, as the same as adding negative 3. So then we've still got negative 2x plus 2. So this is like a middle step, except just thinking about what's going on here, because this subtract is really a sign attached to the 3. And if we're not careful, we'll end up with the wrong sign in front of the things that we have down here. So I'm going to bring this plus down. Actually, I might just stay in red for this. And then we're multiplying negative 3 with negative 2x. So that negative times a negative becomes a positive. I'll just positive 2 times 3 is 6x. So I'm just going to put brackets just around that term so we don't get confused. And then here we've got negative 3 multiplied by positive 2. So this is going to be negative, or take away 6. So really, having this subtract multiplied by a negative thing has made this multiplication here into a positive. So if I just take those away and we combine these into plus. I hope that makes sense. So now we've got 10 lots of x and 6 lots of x. They're like terms, so we can collect those together. 10 things plus 6 things is 16 of those things, x. And we've got positive 15, and we're taking 6 away. So 15 take away 6 is going to leave us with positive 9. I hope that makes sense. Okay, so that's where I'm going to leave this one, expanding and collecting. So these are techniques that we're going to be needing and to be quite comfortable with using when we start doing the linear equations and things like that. Okay, so I'll see you in the next video.